Alright, we're going to look at rotations today. So rotations are one of the four transformations that you need to be able to use and describe. First thing to remember is that rotate is a formal word for turn, and you need to understand measures of turn, so degrees and angles, and you need to know which way is clockwise and anti-clockwise. If you don't know, go look at a proper clock, and the way the hands are going is clockwise. So, rotating Q, which is this shape here, 90 degrees clockwise, about the point 6, negative 6 rather, 1. And that point is called the centre of rotation. That's the point around which all the rotations are happening in this question. So getting your coordinates right, negative 6, 1 is over here. So we're going to mark that with a nice clear cross. And the traditional way of doing these rotations, or the way you're expected to, is to get your tracing paper handy. You will need to make sure both the centre of rotation and the shape fit on the same piece of tracing paper. So this is no use, this is no use. Make sure both fit on. So we're going to mark the centre, and we're going to mark the shape, or at least enough of the shape that we can keep track of where it is. Okay. Now, because this is the centre, this is the place that stays still, and it's the paper, the tracing paper, that rotates. So 90 degrees clockwise is that way. And I'm using my pencil to hold that still. Now, because I've done this humanly with my human hands, this won't be exactly in the centre and this tracing won't be exactly right. But if you look under where this is, you'll see that we're pretty close to proper nice integer coordinates, which means those integer coordinates are almost certainly the right answer. So that means that this is a vertex, this is a vertex, this is a vertex, and these two. And that means we can now reasonably assuredly draw in the resulting image. And images, if we're doing the proper notation, have that little prime indicator. So this is Q prime that we have got here, and that has been turned 90 degrees around this point. So remember, that's not very clear, is it? I've written these lines up for you. So remember that rotations turn things, and they also end up in a different place. They don't stay in place often. Sometimes they do, but often they don't. So the fact that it changed location is fine. That's part of a rotation. So that's how you do them. Sometimes you have to describe them. Now, because this is the rotation video, we know this is a rotation, but you'd have to identify that first, and you can see it's changed which way around it's pointing. That's how you know it's a rotation. And hopefully you can see on that screen that this is T prime and that's T. So we started here and ended up there. We're going this way. So your first mark for a question like this is to say something like T to T prime is a rotation. But that will not get you all the marks, because as we're doing it, you need to know how far and which way and around what point. So the normal way of doing this is again with tracing paper. So you need to make sure that the object that we started with and the centre, which we haven't found yet, fits on the tracing paper. So we trace ourselves around the initial T, and then we just guess what the point might be. Maybe it was the origin. So I hold the origin still, blocking the view there, hold the origin still, and I spin the paper around and it misses. So that's the wrong point, that's the wrong coordinate. And I try a variety of places, and one of them, not that one, so we'll try a different one. Maybe it's over here. No, maybe it's over here. There it is. So that then is the only point which I can hold this piece of paper still and have the trace match up with the original, the object, and the image, the result. And I found the right point. So that point is here. So that we're going to need. And also, we need to know how far we turn this piece of paper. Now, because it's nice right-angled coordinates, we know that that's exactly 90 degrees. And we should know that that's anti-clockwise. So it's by 90 degrees anti-clockwise. around, and that coordinate there is 0, 1. And there you go. That's how you describe them fully for GCSE. And this is a word that trips some people up, or they forget about it. A lot of people try to do it in 2 transformations, even though the question asks for 1. Because you could just turn this in place and then slide it over, which would be a rotation and a translation, but the question asks to do it in 1 single step, which is why you need the correct centre to make sure the movement happens as well as the twisting. Finally, and not essentially, this next bit's extension, so you can stop here if you're happy with this and just happy getting GCSE marks, but if you want to see something interesting, what if it's not on coordinate paper? And what if we haven't got tracing paper? There's a way to construct the centre using our, tools. So, we need to make sure we keep track of which vertex is which. So this vertex here became this vertex here. Shall we say that this is L and this is L prime, so we're going that way. It turns out that the perpendicular bisector of these points must go through the centre of enlargement. Because centre of enlargement is the centre of a circle, and this will be the chord. This will be a chord on the circle because these 2 points will be on the same circle. So if you bisect a chord, you get the centre. That's a circle theorem that you'll do some point later. So open that up to some sensible size. Sloop round. Sloop round. And you'll see I've now got 2 crosses. If I get a proper ruler out and join those crosses up, we know that that must go through the centre of the circle that these 2 points are on. Now there's lots of circles with those 2 points on, but they don't all also go through other points. So let's look at these 2 places now. And if we join those up in a similar way, you can see why this isn't the standard method at GCSE, because it does get quite messy and fiddly, and you have to track all things going on. So that there, where they cross, looks like it should be the centre of rotation. And we can use tracing paper to check this if we like. So if we trace L, hold that point still, that's pretty close. That's pretty good actually, I'm pretty impressed with that for the first time. And that lines up with that, so we found the centre by construction directly. So this would be a rotation clockwise around, let's call this place C. But how far? Well, we can measure that. If we join that to the centre and join that to the centre, that angle is how far round it's turned. And this is 113 degrees. 113 degrees. So even if it's not a pleasant number and it's not on graph paper, you can do this anyway through construction. You're not required to do that GCSE, but it's interesting to know that this works. And if you are doing actual work with stuff that actually moves in circular patterns, like electrons in atoms, or cogs and pistons, or any mechanical device that has circular motion involved, this principle is actually what's going on behind the scenes when you do the algebra to solve all that. Okay, have fun with rotations.